So let's start our discussion. So we have few topics for the day. First is the introduction to RAN and Open RAN. It's just a quick preview or run through about what is radio access network, which we already discussed last week with Engineer Nika of MASCA. And next is the Open RAN. What is Open RAN? What's the difference of RAN and Open RAN? And then I'll introduce you who is ORAN Alliance. And then we'll end with the key learning points. And if we have enough time, we'll proceed with the Q&A. Okay, so this course actually covers the ORAN Alliance, several use cases, introduces what is Open RAN, so what's the difference between the radio access network, okay, and particularly which are the differentiators and why are the other parts of the world are going for an Open RAN system. Okay, so we will discuss this in this session. Okay, so let's start with the introduction to RAN and Open RAN. So last week, Engineer Nika already discussed this with you. So if you're one of those participants, you are very familiar with the slides. So let's just have a quick preview of what composed, or the wireless telecommunication system. So this is the network is composed of mainly three parts. So we have the user terminals, okay, or the RAN or the radio access network, and the core network, okay? So the one that connects the mobile terminal or the user terminal to the core network is the radio access network, okay? And the one connecting the user terminals and the radio access network is the air interface, or we are using an invisible connectivity that we call the electromagnetic energy, or using the radio frequency, okay? And the user terminal could be a 2G, which we call the mobile station, or a user equipment, which is 3G, 4G, or 5G. And the radio access network can also function or work as a 2G, 3G, 4G, or even 5G. And then the connectivity of the RAN going to the core network could be through microwave, wireless connectivity, through fiber optic, or through satellite. Also in different parts of the world, or parts of the Philippines where there's a problem in terrain, or connectivity of fiber or microwave. So it's just connecting 1, 2, and 3, So the user terminal is connected to the radio access network, and the radio access network is connected through the core network. So in all wireless system, even if it's 2G, 3G, 4G, or 5G, we are looking at the same architecture. So you need to have a user terminal, you need to have a radio access network, and you need to have a core network. And then you can implement this architecture for 2G, 3G, 4G, and even 5G. Now, the radio access network could be open or could be traditional. Okay, so in this portion, we will focus on the radio access network. And actually, the user terminal does not care if it's a radio access network, a traditional, or an Open RAN system. It doesn't care, okay? As long as it is compatible with the frequency and the technology and has a subscription to the core network or operator, okay? Okay, so yeah, last week we also discussed about the nationwide mobile coverage. We know that the radio access network, which is composed of cell sites, which are also composed of tower structure, antennas, remote radio unit, CPRI, feeder cables, and baseband unit, okay? These are the composition of a cell site. And the group of cell sites, we call it the radio access network, And we put this in different parts of the country or different parts of the world to have a mobile or seamless coverage. Okay, so in the case of the Philippines, we are building a lot of radio access network to have a seamless coverage for each technology, 2G, 3G, 4G, or even 5G. But you will see that the concentration of the newer generations are located in the densely populated areas, So where technology are being used by different subscribers, okay, like for 5G. So particularly in NCR and in some major cities like Metro Cebu, Metro Davao, Mega Cavite, Mega Laguna, and Mega Batangas. Okay, and also in Baguio City, Mega Davao, and Metro Cebu. Okay, so operators need to build different cell sites, no, in different parts of the country, but they have a lot of challenges, no, for us to have a seamless coverage and mobility. So what are those three major telco operator challenges that they are facing? Okay, first is the faster time to market. Okay, so whenever there is a new technology like 5G, and new features like massive MIMO, services, and capabilities, so they need to be fast, no, to deploy it. Okay, and deploying a fast rollout to the market requires significant investment in new networking technologies. Okay, and it also involves flexibility. So when they try to assess yung mga towers nila or yung mga current cell sites nila, are these cell sites capable of just activating the feature of 5G? Or do we need additional antennas? Do we need additional radios? Do we need additional software? Do we need additional licenses to activate? So it dictates, no, how flexible the current network is. Okay, and sometimes if you deploy a new technology, particularly 5G, you need additional hardware. Specifically, if you're using new frequencies, like in the 3.5 gigahertz, so you need to have a new antenna, a new radio, and you need to have activation licenses and software. Okay, so this is the number one, faster time to market. And number two is, of course, better performance. Better performance that expand and improve system capacities. Especially it happened during the pandemic, where there's a spike of subscribers and user demand, because most of the people previously are working in their offices, now migrated inside their home. Okay, so, and if you are inside your house, sometimes the coverage is not good as it is compared to an outdoor site, no, an outdoor coverage. So we need to have a better coverage. And then if you have a lot of subscribers and then good coverage, you need to balance it with the quality of service. Okay, you need to have a good quality of service. As you increase the number of cell sites, and then you increase the number of subscribers, so there is a potential of having a challenge in the quality of service. So it's a balancing coverage, capacity, and quality. Okay. And then, of course, after deploying this, operators need to lower the cost. So lower the cost in terms of hardware, software, operations costs, capital costs. No? And one of the costs that they're facing is the energy consumption cost. Okay. Equipment cost. And we also have this, what we call the CAPEX and the OPEX. CAPEX means capital expenditure. OPEX means operational expenses. Okay. So CAPEX means if you, for example, you buy a car, so this is the cost of the car. So CAPEX, capital expenditure. OPEX is the operational expenses that you spend to maintain the car. For example, gasoline, insurance, repair and maintenance, driver, mayaman ka. Okay. So those are the OPEX. Okay. So now we are introducing Open RAN, no, to address these telco operator challenges. So this is where Open RAN comes in. So what is Open RAN? Open RAN means Open Radio Access Network. And this is an industry movement. So this is actually not a new technology, but this is a new philosophy. This is a new philosophy of implementing a radio access network. Because as you will see, the comparison between the traditional and the Open RAN, if you look at it physically, you will see a very minimal difference. Okay. So that's why we call it a new philosophy of implementing an open RAN. And then most of the operators that deploy Open RAN, for example, Dish Wireless in the United States, they said that if operator wants to gain the power again, no, so you need to have an Open RAN. So it's Open RAN is a new technology. It's a new mindset. Okay, it's not only a new technology, it's a new mindset. Okay, because in this case, operators will be the one who will do the planning, who will do the implementation and the strategy, not on the other way around, where vendors are really the ones who are leading the deployment of the radio access network. Okay, so these are disaggregated and interoperable radio access network solutions. So meaning what, when we say disaggregated, we are separating the component of the hardware to the software. Okay, it's not anymore just like you buy the whole package of one radio that includes the software again. So in this case, for example, in the centralized unit, you can buy a typical Dell server, and then you can install the software of another vendor like Pioneer or Parallel Wireless. Okay, that's why it's called disaggregated. And when we say interoperable, meaning you are not mandated to buy the same or the same brand or from the same vendor of these two equipment. For example, the centralized unit, the distributed unit, and the radio. Currently, right now, this is bought in one single vendor. But if you go for Open RAN, there's a promise of interoperability. You can buy from vendor A, buy from vendor B, and buy from vendor C. Okay, and then they can interoperate with each other. Okay, so it's a multi-vendor solution. Okay, so it's an interoperable radio access network solutions that leverage the general purpose processors hardware, so GPP. So just like a typical OEM hardwares. And then the software-defined technologies, okay, the one that was described or discussed by Liver a while ago. And of course, open interfaces. So right now, the interfaces must be open so that you can connect one equipment to another equipment from another vendor so that it can support the multi-vendor, okay, scenario, okay? And of course, all of those technologies or interfaces and protocols are based on industry standard, which is, for example, in LTE and 5G, it is based on a 3GPP standard, okay, or third generation partnership project standard. And of course, the Open RAN has different pillars, so it should be open, okay? Meaning open, it's not open for everybody, right? Open means you can see the hard code, okay? And then you can also there's a separation of hardware and software, okay? And then you can also virtualize the functionality. So the functionality of the baseband, for example, you can virtualize it and then install it into a typical server or any server that will fit your requirement. And then of course there's an intelligence. Later on, you will see where does the intelligence comes in, particularly the RAN intelligent controller, and of course the programmability. So you can program how your radio access network will work. Okay, so this is the overall definition of an open RAN or an open radio access network. So if we compare it with a traditional network, you will see that open RAN is something, there's a similarity, especially if you look at it in a hardware perspective. But for example, in traditional RAN, so the protocol stack that runs on the proprietary hardware. So the hardware is proprietary, okay? The BBU or the radio unit and the BBU are connected via a proprietary interfaces. So meaning for example, the CPRI, the Common Public Radio Interface, is also proprietary. And it's a single vendor that provides both the radio unit and the BBU. Meaning if the operator wants to implement a traditional run, so they need to work with a single vendor to purchase the BBU and the CPRI and the RRH, no? Or the RRU. So if this is vendor A, so this is vendor A. Okay, so there are cases that operators use more than one vendor, but operationally or strategically, they deploy it in a separate geographical area. For example, there's another vendor in the northern side of the country and another vendor on the southern part of the country. And in some areas or wide countries, so some of them are located in the west part or the eastern part. Okay, so there's a different vendor groupings or geographical assignment of vendors, no? Just to simplify the operational procedure or operational process in the company. Okay, but definitely you need to buy one equipment or software from one single vendor. So what's the main difference for Open Run? So for Open Run, so this is standardized software centric approach based on commoditized hardware. So you can have a general purpose processor like a Dell or HP, okay? And then you can virtualize the functionality. And then open standard interfaces. It uses the open standard interfaces that ensure the deployment of multi-vendor RU and CU DU ecosystem. So it is powered by an open source AI/ML based platform designed for non and near real-time rig. So later on, we'll talk about non and near real-time rig. Okay. So there are benefits, no, of Open Run. First benefit is diverse vendor ecosystem. So which will remove the vendor lock-in. So that's the term, vendor lock-in. Okay. So meaning hindi ka nakatali sa isang vendor lang. Okay. So it will allow you to a more competitive supplier environment. Okay, just imagine if you have a laptop and then you want to replace your random access memory, no RAM, or you want to buy another hard drive or hard disk, okay, from another vendor, and it can still work. You can buy different keyboard, okay, it still can work, no? Yeah, so it's more it's more freedom, no, sa pag-implement ng radio access network. And then faster network deployments, no? Kasi sa automation, Dish, for example, they mentioned, if I'm not mistaken, they can deploy one cell site, no, per minute. Okay, so ganun sila kabilis, no, mag-deploy ng cell site. And centralized radio architecture. And they also have new innovation models introduction. So if you have this new innovation model, so it will make more accessible to third-party software developers. So if you have other developers that has a new innovative idea, okay, you can implement it on your network. No, you don't need to wait for your existing vendor, no, to provide it for you. Yeah. Of course, there's also data-driven based on artificial intelligence and machine learning. So later on, mamaya pag-usapan saan lalabas yun. Okay. And they're looking at a lower total cost of ownership. Because essentially, if you use a white box, a hardware or general purpose processor, it's in terms of cost, it's lower than the typical equipment, no, coming from the traditional vendor. And it will also reduce the time to market and reduce the time of deployment. Okay. Okay, so those are the benefits, no? Some of the benefits, no, for foreseen benefits. And then for challenges, of course, there's a challenges. So number one is network performance. So there's a common concern regarding Open Run with its ability to match the performance of the proprietary hardware platforms. So, but in the recent lab trials that we have seen and live deployments addressed at the that we have seen, no? So there's a proof that Open RAN is meeting performance objectives. If you look at the Rakuten's website, they are comparing the performance of their network compared to other vendors worldwide. Next is fault management. Okay, so when everything or when something goes wrong in the network, isolating the component that is source of the problem can be more complex in an open RAN environment. Totoo yan, no? Kapag may isang nasira dyan. So, question is, who will fix it? Yeah, okay. So, to solve this challenge, so there are a lot of network management tools that have been developed for Open RAN that will contribute to in the root cause analysis and speedy issue resolution. Okay, so in-anticipate din yan, lalo ng mga developers. Network automation. Okay, so to fully realize the benefits of Open RAN and to manage the complexity, operators must invest in the cloud management technologies, no? Like for example, sila Amazon, AWS, okay? And extreme automation, including mga orchestration, and then the zero-touch provisioning or the ZTP. Okay, so magkakaroon tayo maraming automation dito. And then understand the Open RAN ecosystem. So this is one of the challenges. That's why this is one of the mission of Asia Open Academy. No? So one of the biggest enhancement to Open RAN is to end the vendor lockdown age. Okay. So in the new Open RAN environment, as you realize, no, during our series, so we started cloud computing, edge computing, radio access network, and then now we discuss about virtualization, software-defined networking, and then later on we'll have the artificial intelligence, no, on the next series. So it is very important that everyone involved is aware of all the new hardware and software that currently exist, and as well as all providers. So this for this issue, there are several initiatives, no, were born to help companies understand and begin in this journey. That's why Asia Open Academy is one of those entities that helps the workforce development. So if you're planning to dive into Open RAN, it's not enough for you to know the basic telecom. No? That's why we are also encouraging everybody that the emergence of the Open RAN has introduced a new breed of telecom engineer or an IT engineer because it's a hybrid. It's a combination of, if you will see, no, the topics, it's a combination of telecom and ICT or IT. So there's a merging of these two industries, telecom and IT. So it's not anymore computer engineer ako, IT ako, or ECE ako, no? It's a merging of it's a merging of skill set. So if you want to go in this type of industry, you need to learn telecom, you need to learn IT. You need to learn IP, you need to learn SDN, virtualization, artificial intelligence, and even programming. Okay. So it requires a new breed of engineers or what do you call technology experts. It's a hybrid type. Okay, so if you want to go to become a hybrid, there's a lot of things that you need to learn. So if the requirement of OpenAI is like that, so it does not only mean challenges, it also means opportunities for everybody. Okay, opportunities for an ECE a student to touch one of these important points, no? Not necessarily naman maging expert ka sa isang field, no, or sa lahat ng field, no. At least nandoon ka sa cloud computing or edge computing or nasa radio access network or even nasa virtualization or nasa SDN part or nasa artificial intelligence part. Okay, so there's a lot of opportunities that are that are brought, no, in the emergence of Open RAN. Okay. And of course, new team profiles. So operators are also now preparing. Okay. Because as I mentioned, the lines between the world of telecommunications and the world of IT is nagiging blurred, nagiging malabo. No? So it's going to be a mixed skills or skill set. So this implies that the roles and responsibilities defined so far within the world of these networks change with the arrival of Open RAN. Okay. And for this reason, one of the challenges that companies may face, particularly operators, is adapting their teams and knowledge to this new way of deploying networks. Okay, so you need to train your existing manpower or your existing talents. Okay, so these are the challenges of the Open RAN and the benefits. Okay, now let's move on to Open RAN groups and initiatives. So who are the different organizations that support Open RAN? First is 3GPP, the third generation partnership project, which was established in 1998. So they are the one who defines the 3G, 4G, and 5G standards, including the functional split, like the splitting of the baseband functionality into centralized unit and the distributed unit. Okay, so 3GPP yan. And the radio access network, so 3GPP rin yan, which underpins Open RAN and the F1 mid-hole between the DU and the CU. Yeah. Okay, so nandiyan si 3GPP. So kung ano man yung guidelines or protocols or standards na ginagamit ng LTE, 5G sa existing traditional network, that will also be the same when you implement Open RAN. Okay, so if you already understand that the protocol of 4G and 5G or 3G, it will be the same for an Open RAN system. Okay, that's a good news. Next is Telecom Info Project. Telecom Info Project was established in 2016. So they are also known as Meta or Facebook. So this is a Facebook funded, no? Yeah. So established in 2016. So Open RAN was first conceived by TIP, and TIP has a multiple Open RAN product implementation project groups. So they are also the one who are conducting the Plug Fest. No? They are the one creating this ecosystem of Open RAN. Yeah, nag-invite sila ng mga different players. No? So dali mo equipment mo, dali mo yung software mo. So let's have a functionality test, no? Or Plug Fest. Tingnan natin gagana sila. Yeah. So they're the one engaging in that kind of ecosystem. Of course, nandiyan si Oran Alliance. Yeah. Oran Alliance was established in 2018, developing architecture and specifications for Open RAN. So anything na bago interface or functionality other than the technology ng 4G or 5G, sagot yun ni Open RAN, ni Oran Alliance. Okay, Oran Alliance will take care of it. So later on, makikita nyo nasa inyong mga specifications na yan. Lalo na yung mga bagong interfaces na gagamitin natin sa Open RAN architecture. Nandiyan din si ETSI, the European Telecommunication Standards Institute, that promotes Open RAN adoption in Europe. Yeah. So you will hear these familiar organizations, right? GSMA, or the GSM Association, represents the global telecom operators, helping operators commercialize Open RAN. Who else? The NGMN. Okay. NGMN is the next generation mobile networks. So they are the ones collaborating with the Oran Alliance to accelerate the standardization and adoption of Open RAN for 4G and 5G. Of course, the Linux Foundation. So they are non-profit consortium created in 2020, bata pa, diba? By open source development and free standards group. So they promote and standardize the Linux for commercial use. So it's a software development for Open RAN. Okay. ONF, or the Open Networking Foundation, contributing SDRAN to support the ORAN Alliance, defining vertical disaggregation standard or the RAN intelligent controller. Meron tayo sa mga IBS or mga indoor solutions like the Small Cell Forum or the SCF. So they are the one developing standards for small cells and front hole interfaces, including the FAPI, ayoko na sabihin FAPI, no? FAPI and the non-FAPI, no? Yeah, Network Functional Application Platform Interface. Okay. So these are the parties or organizations that work together to avoid the duplication of work para hindi overlapping. Use the same standards, support development, and encourage adoption. Okay. So ito yung mga different groups and initiatives. So from here, we will focus kay ORAN Alliance. Okay, sino ba si ORAN Alliance? So kung dati, nag-aaral tayo ng 4G and 5G, so we want to know the standards, protocols, ano yung nangyayari sa loob ng cell site, ano yung nangyayari sa loob ng UE, how they communicate with each other, what are the different protocols, what are the different layers. We are looking at that in 3GPP, third generation partnership project. So they are the ones who created that standard and protocol. So you can also browse their website. You can see the different release. No? Nandun yun, release 16, 15, 16, 17, 18. Now we are on the release 19. Okay? So ORAN Alliance naman, so katulad siya ni 3GPP, but now this is focusing on the Open RAN system. So sino si ORAN Alliance? So ORAN Alliance was founded in 2018. But it is composed of two entities. Okay? First, I see CRAN Forum. So it was founded in 2009 by China Mobile. Okay, so they are the one who first proposed to the industry the concept of centralized, collaborative, cloud and green radio access network. Okay, and then we have the XRAN Forum. Okay, XRAN was founded in 2016 by AT&T, Deutsche Telekom, and others. Okay. So the goal is to develop and standardize and promote an open alternative to the traditionally closed hardware-based RAN architecture. Okay. So nagsama yung dalawang yan noong 2018, and the founding operators was AT&T sa US, China Mobile sa China, Deutsche Telekom, NTT Docomo, and si Orange. Okay. So ORAN Alliance was formed by combining these two, the CRAN Forum and the XRAN, on February 27, 2018, with the goal of promoting open and intelligent RAN. And this is the second organization driving the Open RAN movement. Okay. Ang una ay si TIP, si Telecom Infra Project in 2016, which is a Meta-funded project. And then sumunod si ORAN Alliance. Okay? So, sino again si ORAN Alliance? So, this is a group of telecom companies that aim to improve the performance and openness of their networks. So, they call for more intelligence in the network through information collection for these virtualized network elements. And artificial intelligence and machine learning can then be applied to this collected information. Okay? So let's see, with this video, kung sino si ORAN Alliance.
Transforming radio access networks to be open, intelligent, virtualized, and fully interoperable is not a far-off vision. The ORAN Alliance has made this vision real. Since 2018, the adoption of the ORAN Alliance by the industry has been incredible. It has grown to a worldwide community of operators, vendors, and research and academic institutions jointly developing a sustainable ORAN ecosystem. Through expanding traditional mobile networks, the ORAN Alliance has created its ORAN architecture to become a foundation for truly open and intelligent radio access networks. The ORAN architecture improves the RAN in several areas. First, the ORAN architecture supports disaggregation of software from the hardware and network virtualization. Underlying open reference design hardware and the O-Cloud provide a high-performing and scalable computation layer. Second, The O-RAN architecture is based on well-defined open interfaces to enable a multi-vendor, interoperable supply chain ecosystem. Third, the O-RAN architecture empowers mobile networks through artificial intelligence and machine learning. O-RAN networks can self-optimize to ensure the best possible service for the end customers, and automated operations and maintenance enable more efficient network rollout and operations. Defining the complex O-RAN architecture is a step-by-step process, resulting in hundreds of technical documents. To ensure compatibility and to avoid duplication of work, the O-RAN specification effort builds on common standards and cares about alignment with other industry bodies. O-RAN specifications serve as a basis for open software reference design. The O-RAN software community hosts developers brought in by many O-RAN players, cooperating on tens of software projects. O-RAN specifications in open software are enabling a broad industry ecosystem. Companies of different sizes and competencies can use them to create their innovative and competitive open solutions. In addition to specifications, O-RAN Alliance supports the ecosystem in testing and integration. O-RAN Global Plugfests allow companies to demonstrate component functionality as well as multi-vendor interoperability. Moreover, the open testing and integration centers around the world will offer a collaborative and impartial testing environment. O-RAN supports implementations using open source modules, proprietary modules, or any combination. Operators and suppliers can create different paths and approaches to implementing O-RAN, optimized for their specific network and customer needs. The rapidly emerging O-RAN ecosystem has enabled service providers on multiple continents to start field trials and commercial deployments, aiming to build significant parts of their networks based on O-RAN technology. Open, intelligent, virtualized, and fully interoperable, O-RAN-powered mobile networks will soon be serving billions of people around the world. The O-RAN Alliance.
So, going back, no? So, meron tayong mga general purpose processors like Intel or NXP, AMD and ARM, specialized chips, specialized chipsets, and RF analog, no? Yung mga RF unit frontends. So these are the players, no, in the semiconductor. Yeah. Chipsets and components. Yeah. Sorry, hindi ko nakita na wala pala akong audio. Okay, thank you Tony for letting me know. Okay. Ayun yung ating mga opportunities na nakikita sa semiconductor. What else, no? In terms of the O-RAN software. Yan, ito mas medyo marami dito. So, just to note, no, hindi lang ito yung mga players, no. Yung mga if you watch the video dun sa isa sa mga sessions with E3 sa Taiwan, so maraming companies din ang nagde-develop ng sa semiconductor field, no, about the Open RAN. Okay, now in the software could be divided into three: the RAN software nung distributed unit and the centralized unit. Okay, yeah. So ito yung mga bare metal. It could be a bare metal, virtualized, or containerized. Okay. So these are the software ng distributed unit and the centralized unit that is meant to run on the third-party hardware. So nandyan sila Capgemini, JMA Wireless, Mavenir, Nokia, Parallel Wireless, Radisys, Rakuten Symphony, and Samsung. Okay, so again, it's not only the list. No? There's a new players coming in. For the RAN Intelligent Controller or the RIC, so these are the software used for controlling and optimizing the RAN functions, including the near real-time and the non-real-time RIC. Andyan ulit sila Cellwise, sila Ericsson, HCL, Juniper, Networks, Mavenir, NEC, Nokia, and VMware. For the service management and orchestration, or like si SMO, for automation platform, okay? Yung mga Open RAN resources natin. So Amdocs is there, Sienna, DZS, HCL, High Street Technologies, and then Samsung. So ito yung sa Open o RAN software. How about services? Yan. So services, so for implementation, integration of the system. Yan. So nandyan yung system integrations. So sila yung magbubuhay ng mga Open RAN system. So these are the companies that provide engineering services to integrate the O-RAN networks. Accenture is one of them. Infosys, Capgemini, NEC, Hewlett-Packard, Tech Mahindra, IBM, TCS, no? Yan si Tata Consultancy Services. Andyan din yung mga test and measurement. So these are the companies that provide equipment services for development, validation, and deployment testing. So I believe some of you already familiar with Anritsu, okay, si Keysight, Viavi, Roden Swartz, Calnex, and Spirent. Okay. In terms of the enterprise services, so these are the companies that service enterprise customers, which include service operators, Cellnex, Cisco, Ericsson, Nokia, and ServiceNow. Yeah. So ito yung mga companies na titignan nyo, no? O-RAN hardware. So ito naman yung mga hardware per se, no? So yung mula open radio units, yung mga RRU natin, which are now open. Kasama dito yung mga RF, lower physical layer, and yung mga front hole interface. Nandiyan sila AirSpan, Bicell, Comba, Comscope, Foxconn, Fujitsu, KMW, Mavenir NEC, Sercom, okay, and WNC. For the DU naman, distributed unit or the OCU, ito yung parang baseband natin, yung pinakita ni Nika last time. Andiyan sila Dell, for the server, si Hewlett-Packard, si Contron, Supermicro, and si QCT. And for the full run, we see also yung mga existing vendors like Ericsson, Nokia, and Samsung are going, no, for various levels of the O-RAN compliance. Okay, so like for example, the Nokia, they're starting to have this Open RAN baseband unit. Okay. Yeah, so yan naman yung atin sa O-RAN hardware. Now for the cloud, I believe familiar din kayo dito sa mga cloud. So cloud is not anymore focusing doon sa mga cloud computing natin. No? So yung mga cloud hardware like Dell. So these are the servers and accelerators comprising yung mga hardware meant to run sa cloud or edge platform. Ayan si Dell, Hewlett-Packard, Contron, Lenovo, and Vapor. And yung mga cloud software, I believe familiar na kayo dito. Almost all familiar kayo. So these are the software frameworks used to manage and run the cloud platform. Like for example, Dish, they are running their core network sa AWS. Okay? And then yung mga data centers nila is also powered by AWS. Canonical, Google Cloud, Microsoft Azure, Red Hat, SUSE, VMware, and Windriver. Public cloud providers. So these are cloud providers hosting RAN functionalities. Okay, ito. So andyan si Oracle, si IBM Cloud, Azure, Google Cloud, and AWS. Yeah. So if you're in this kind of domain, no, so you still have opportunity for Open RAN. Okay. So maybe mga hindi mo makikita na nagde-deploy na pala ng Open RAN, and then one of your key skills is nasa cloud. So you can also contribute sa Open RAN ecosystem. Okay, it's not only about telecommunications. It's as I mentioned, it's a merging of IT and telecommunication skill set. Okay. Okay, so now let's see. Have a preview sa Open RAN logical architecture. So ano ba yung Open RAN logical architecture? So you can see this one sa working group 1, no? Yung O-RAN architecture natin. So sa taas, makikita nyo, nandito si SMO, the Service Management and Orchestration Framework, or SMO. Yan. So small layer. So sa SMO is nandun si non-real-time rig. Okay. This SMO is handling the deployment and configuration, as well as yung mga data collection. For example, RAN observable captures yung mga non-real-time rig functionality. Mga enrichment information that can enhance yung mga RAN guidance and optimization functions. And yung mga AI and ML workflow. Yan, yun nandiyan din yung training and update ng mga machine learning models as well as yung mga functions for the deployment ng mga machine learning models and other applications. Okay. And one purpose of the SMO is to optimize the run performance towards the fulfillment of the SLAs in the run intent. Okay. Yeah. Now the SMO is connected to different parts of the network. For example, we call the interface of non-real-time rig to near real-time rig as A1. O1 for the OE node B if you are connecting an LTE, okay, node to the SMO, and O2 going to the O cloud. Okay, so we also have the open front haul M plane for the ORU. Okay, so there's a lot of interfaces now that you will memorize. And if you will see, these are combination of 3GPP interfaces and the ORAN interfaces. So itong mga gandong kulay, these are the ORAN interfaces. So this is the one that, these are the interfaces that are defined, okay, and managed by the ORAN Alliance in terms of specifications. Okay, so these are the interfaces. The O2, O1, A1, O1, E2, E2, okay, si open front hole, okay. Ito yung mga, these are the interfaces. And for the 3GPP interfaces, so these are the typical interfaces, for example, the connectivity of OCU, the um, centralized unit control plane, E1 interface that connects the user plane of the centralized unit. Then you also have the F1 control plane and the F1 user plane. So that connects the ODU, no, to corresponding control plane and user plane. And of course, yung connectivity of our nodes going to our core network, okay, or to other node Bs or E node Bs or G node Bs, we call it the X2 control plane and the X2 user plane. And then going back to the core network, if it's 5G, it's NGU user plane, okay, and NGU control plane. Okay, so these are the different nodes, no? Yeah. So the E2, so where's the E2? So the E2 nodes, these are the E2 nodes. You will see the E2 nodes here, E2, E2, E2. So this is the logical node that terminates, no, the E2 interface, no, yung mga E2 nodes. We are saying ito yung mga E2 nodes, no. Yan. Yeah. Okay. And then we have the near real-time rig. You will see the near real-time rig. Okay. So the near real-time rig or the non-real-time run intelligent controller. So this is a logical function that enables near real-time control and optimization of run elements and resources. Okay. So it might include yung AI or ML workflow, including yung training ng ML model and inferences and some updates. Yan. Okay, so maraming parts, ano. But this architecture is being discussed sa run intelligent controller and yung sa deep dive ng Open Run architecture. We're just having an overview what is the components, no, of an Open Run logical architecture. And then the OCloud, OCloud is a cloud computing platform, okay, comprised of physical infrastructure nodes that meet the Open Run requirements to host the relevant ORAN functions. Kasama dyan sila near real-time rig, si OCU, UP, CP, ODU, that supports yung software components, no, also. Kasama yung mga OS, mga VM monitor, container, runtime, and others. Okay. So this is appropriate for the management and orchestration functions. Okay. Yeah. And then yung iba, yung centralized unit, this is like the baseband functionality nung ating typical baseband. So meron tayong ORAN central unit control plane, okay, the CP. So this is a logical node hosting the RRC and the control plane part of the PDCP protocol. Yan, yung nabanggit ni Nika, no, na mga protocols. The UP, the OCU-UP, or the ORAN Central Unit User Plane. So ito naman is logical node hosting the user plane part, the PDCP protocol and SDAP protocol, no, if you're using a 5G. And then for the DU, it's a distributed unit. So ito yung merong RLC, MAC, high physical layers, no, based on the lower layer functional split. Yeah. And then kapag LTE naman, this is for the eNode B. Yeah, that supports for the E2 interface. Yeah, may connectivity tayo dyan. Okay, so that is the logical architecture of Open RAN. Okay, so pag tinignan mo siya, ganito itsura niya, no? Kapag inano natin sa ano. So this is a typical scenario of an Open RAN system. So this one from Mavenir. So this one cell site, no? Kasi yung iba, yung the other functionalities like yung RAN intelligent controller, the SMO is not here. It's on the core side. But if you will see, there's an antenna, it's a typical antenna. So the antenna could be a single band, multiband, or a massive MIMO. Okay, it depends on the implementation. And then you have the remote radio unit like this, the RRU. So these are simple type of RRU. And the CU and the DU are here. Yan, nandito. So kaya kapag dinignan mo, no, halos parehas siya ng ano, typical radio access network. Now there are different ORAN setup also. So you will see in the market, for example, for Firecell, there is a lab kit. So if you want to study about the different protocols for 4G and 5G using an open source system, so there's a Firecell 4G and 5G lab kit. You can propose this to your universities to buy. Okay. And then there's an interoperability lab. So in one of the plug fests, ganito yung setup nila. Okay. So nandito yung nandito yung ating NMS or emulator, merong emulator, RF channel emulation. This is the system under test, which is an ORU, and there are also an open fronthaul emulator, no. Yan. So emulator is the one na parang ginagaya niya, no, yung functionality ng isang system for you to be able to test, no, yung magiging functionality ng iyong device. It could be the CU, the DU, or the RU, or the RAN intelligent controller, or even the core. So kapag nag-set up sila, so they're using an emulator. So for example, you're trying to to test the functionality of your CU or the centralized unit, so you need to have an RU emulator, no? So that you can emulate also yung RU. Yeah. Or you can also have a UE emulator. So iginagaya mo naman yung functionality ng isang user terminal. Okay? So if you want to define, for example, 1,000 UEs or 10,000 UEs to connect to your Open RANs, you can do that inside the lab. So you don't need to purchase 1,000 telephones or mobile phones. Just use this UE emulator, no, to test, no, yung functionality ng iyong system. So these are for the interop lab. And then for the community networks or deployment, so this is how they are defining it. Okay, so meron mga indoor, outdoor. So typical nandiyan yung RU mo. Okay, and then your RUs are connected to a front hole gateway. Okay, so ini-integrate natin sila sa isang gateway going back to the BBU or probably the distributed unit and the centralized unit kung magkahiwalay sila. So this could also be deployed in different scenarios like this. So the front hole gateway BBU is the central part, and then you can distribute the radio unit, no, in different establishments or houses. Yeah. You can also deploy it in indoor. Okay, so it's the same concept that we are using in the deployment of radio access network. Okay, ayan. So what are the benefits, no, of the ORAN architecture? So first, the ORAN architecture can reduce network capex and OPEX, no? Syempre, economy of scale. So once na maraming gumamit, once there's a lot of operators use Open RAN or deploy Open RAN, so eventually the cost of producing this equipment will go down. Yeah. So that's why there's a capability of reducing the capex through multi-vendor ecosystem with scale economics. Yeah. Okay. What else? ORAN can improve network efficiency and performance. Okay. So ORAN is capable of improving network efficiency and performance. So it simplifies network efficiency and performance with the RAN automation. Okay. So with ORAN, status of the network performance and network resources are continually monitored, and more real-time closed-loop control, okay, could take effect with little human intervention. Yeah. And of course, ORAN can import new capability with great agility. Yeah, so ORAN makes it easy to import new network capability via easy software upgrade with its native cloud infrastructure. Okay? Yeah. So ito yung mga different benefits of ORAN architecture. And of course, there's use cases that the ORAN Alliance has looked into. So initially, they divided into phase 1 and phase 2. So phase 1 and phase 2 implementation of the use case or use cases. So sa phase 1, kasama dito yung mga low cost, okay, white box hardware, including the ODU and the ORU. Okay, so that could potentially reduce the cost of 5G deployment. Nandito rin yung traffic steering. So traffic steering is the evolution of mobile load balancing. So yung nangyayari na yan sa network natin. So you are distributing the different subscribers into different bands. So to optimize na yung performance and yung user experience. Quality of optimization. So if there's a demanding 5G native applications, okay, that needs to have higher priority in the network, okay, so and also to improve yung experience ng subscribers, so that is also part of the phase 1. And massive MIMO optimization, okay, so this is seen as one of the key technologies for 5G. So if you are deploying 5G, at least you must have a massive MIMO so that you can maximize the capability of 5G. Okay. What else? QoS-based resource optimization. Okay, so that you can have different priorities in the network. Like for example, in terms of congestion situation. Okay, so you need to have this kind of resource optimization. That is for phase 1. Now for phase 2, they're looking at the RAN sharing. Okay, so RAN sharing meaning for one radio or one CUDU, so there are multiple operators using it. It's not only about using one tower and then different operators will collocate. Now it's a different implementation. One RAN system, including from antenna, radio, and the baseband. So multiple operators can use that, not only the tower. So that is RAN sharing. RAN slice assurance. Okay, so different slices, especially for 5G, which have EMBB, MMTC, and URLLC. So you have different service level agreement assurances. And then context-based dynamic handover waste management for V2X. So especially for countries that are starting to deploy the V2X, the vehicle to everything. And also for the UAV or the unmanned aerial vehicle, ito na yung mga drone applications. So for flight path-based dynamic UAV resource allocation. So yung path nung nadadaanan ng mga drones nyo should have sufficient resource para hindi maputol yung connectivity. And also for applications. Yeah. Okay, for UAV again, for unmanned aerial vehicle, particularly mga drones. Okay.